Lesson 9-1, multiplying and dividing rational expressions. A rational expression is just a ratio of two polynomial expressions. Because variables in algebra often represent real numbers, operations with rational numbers and rational expressions are very similar. So when you are simplifying a rational expression, just treat it like a fraction. So when you are simplifying fractions, you're dividing out the greatest common factor in the numerator and the denominator. Sometimes you can also factor out a -1 either in the numerator or in the denominator to help you simplify a rational expression. We'll see some of those examples in our lesson today. So example 1, we need to simplify this rational expression and then state when the original expression is undefined. If I can factor the numerator, this will give us x minus 6 times x plus 4. Because -6 times 4 is -24, and -6 plus 4 is -2. And in the denominator, I can factor out a 2x. That's going to leave us with 2x times x squared plus 3x minus 4. And now I have to think, what do I multiply to get -4, but add them together gives me 3. That would be a +4 and a -1. Now I look at my numerator and denominator, they both have an x plus 4. So my answer would be x minus 6 divided by 2x times x minus 1. And then when is it undefined? When x, when it's undefined, so when x is, take each denominator, factor the denominator equal to 0, this would be 2x equaling 0, x plus 4 equaling 0, and x minus 1 equaling 0. So this would be divided by 2, x would equal 0, subtract 4, x would equal -4, add 1 here, x would equal 1. So for our answer, x cannot equal 0, 1, and -4. X simplify this one. I have a difference of 2 squares on top, so this would be x minus 6 times x plus 6. And the denominator, -11 times 6 is -66, and -11 plus 6 is a -5. They both have x plus 6 in here, so my answer would be x minus 6 and x minus 11. And then x cannot equal, if I make each of these equal to 0, I would have x cannot equal 11, and it can't equal a -6. Another one from example 1. Simplify this one. So this top one, this is x plus 1 times x plus 1. In the bottom, I had to do the AC method, so this is -4x squared. So I have 4x and a -1x minus 1 and then 4x squared. Factor this and I can take out a 4x. That leaves me with x plus 1. And over here, take out a -1, that's x plus 1. So in the denominator, this would be 4x minus 1 times x plus 1. The x plus 1's cancel off, and I'm left with the letter B. When is the expression undefined? So if I look at my denominators, that would be when x is -1 and when x is a positive 1/4. Example 2, now we're going to simplify using a -1. So if I look at here, I can first, this term and this term are very similar. So to get them to be like each other, if I factor out a -x on top, that leaves me with 5x or a 5y minus a 6x. And And then I also have x plus 2y left up on top. And on the denominator, I have an x plus y, and I have a 5y minus 6x. Now, if you had still negative 6x plus 5y on top, that's still the same. So this divides out that one, and my answer is now negative x times x plus 2y all over x plus y. Next, we have simplified this one. So if we look at the top is a difference of 2 squares. So I can simplify that to be 2x minus y times 2x plus y, all divided by, I do have a y minus 2x, so if I take out a negative 1 down here, that will give me positive 2x minus y, and then I have I'm going to put an x plus 4. I'm going to put my variables first. The 2x minus y's divide out, and now I'm left with an answer of 2x plus y, all divided by negative 1 times x plus 4. Or you could have it as 2xy, or 2x plus y divided by negative x minus 4. Either way, that would work. Next, simplify this one. So I have a 7y and a 3x. They look similar. I need to have a minus 3x. So if I factor out a negative 1 here, this is going to give me a 7y minus 3x times 5x minus 1 all over 5. You can take out a x squared here. This will give me 5x plus 1. And here I have a 3x minus 7y. If I take out a negative 1, then that would make it 7y minus 3x. Now the 7y minus 3x divides out, and now I'm left with an answer of 5x minus 1 all over x squared times 5x plus 1, which that will be choice D. Actually, not choice D. That would be choice A. Yeah, choice A. Because remember, there is a negative out here. I took out a negative, so I have to put that negative back in there. So we would have a negative in front of all that. So that's why it would be choice A. Moving on to our next section. Method for multiplying and dividing fractions also works with rational expressions. So multiplying rational expressions, to multiply rational expressions, multiply the numerators with the numerators and the denominators with the denominators. When we to divide rational expressions, you multiply the dividend by the reciprocal of the divisor. So you multiply fractions, just multiply by the reciprocal. And we're going to see some complex fractions. A complex fraction is just a rational expression with a numerator and or a denominator that is also a rational expression. So to simplify a complex fraction, just first rewrite it as a division expression. So again, you have a complex fraction is a fraction inside of a fraction. So example 3. Simplify each expression. So here, there are a couple ways you can multiply first, straight across, and then simplify, or you can simplify first. I think right now I'll just multiply straight across, and we get 36 x to the third y, and the denominator you got 72 x y to the fourth. Now we simplify. 36 divided by 72 is 1 over 2. And then when we divide like bases, you subtract the exponents. So this would be x squared on top. And then I would have y cubed on the bottom. This would be my answer. Next, since I'm dividing fractions, I'm really multiplying by the reciprocal. So this is 10d to the fifth divided by 6cd times the reciprocal of 4c over 30c cubed d squared. Now I simplify it. This will give me 40c d to the fifth all over 180 c to the fourth d to the third. Now I can divide these by 10 and take a 2 out here, take a 2 out here, and it gives me 9. So right now, my answer, I have a 2 on top and a 9 on the bottom. I can take a c away on top and c away on the bottom, and that gives me c cubed on the bottom. d5 minus 3 is d squared. My answer is 2d squared divided by 9c to the third power. Next, multiply these. This gives me 60x cubed y squared all over 45xy to the fourth. Simplify, I can divide top and bottom by 15. That gives me 15. That would give me, not 5. That would give me 4. 45 divided by 15 would give me 3. So right now I have 4 over 3. X squared on top here, and then y squared on the bottom there. Next, divide, so we're going to multiply by the reciprocal, so 27a squared b all over, this is a cubed b cubed times the reciprocal of 2b squared over 18ab. Okay, do some simplifying. So this is 54 a squared b to the third all over 18 a to the fourth b to the third. So my final answer, 54 and 18, I can divide that by 18. If I divide that by 18, 18 times 3 is 54, so I have 3 on top. And then I have a squared on the bottom, and the b's divide out, so my answer would be 3 over a squared. Now actually, the b's don't cancel off. This is b to the fourth here. So I would have one b left over here. So 3 over a squared b. Example 4, multiply and divide expressions with word problems. There's a manufacturer that creates and sells rectangular planters wants to compare the areas of the top sections of two potential sizes of planters. For some given measure x, the area for the first planter is represented by x squared plus 15x plus 50 divided by x plus 2, and the area for the second planter is represented by x squared plus 30x plus 20 or 200 divided by x plus 2. Write and simplify an expression that represents the ratio of the area for the first planter to that of the second. For this one, we're going to write it as a division because as a ratio, it's going to be your first planter divided by your second planter. So if I'm dividing them, I'm really multiplying by the reciprocal. So I'm going to simplify these. I'm going to factor this one, so this will be x plus 5 times x plus 10. This is x plus 2 here. Now I got to multiply by the reciprocal, so this would be x plus 2 on top. On the bottom, this would be x plus 20 times x plus 10. Look at here, I'll simplify with common factors in the numerator and denominator, so x plus 2's divide out, x plus 10's divide out. And my answer is now x plus 5 all over x plus 20. And I can't simplify that any further, so that would be my answer. Next, consider a rectangle area a squared, x squared plus 5x plus 6 divided by x plus 1. If the rectangle were one face of a rectangular prism with a depth of x squared plus 4x plus 3 over x plus 2, write and simplify an expression that represents the volume of the prism. So again, volume is area of the base times the height. So if we have the area of the base, so area of the base times the height, find the volume. So we need to write an expression that represents the volume. So the area in factored form would be x plus 2 times x plus 3 all over x plus 1. Okay, I'll multiply that by the height, which that would be x plus 3 times x plus 1 all over x plus 2. If I simplify it, the x plus 2 divides out, and the x plus 1's divide out, and I'm left with x plus 3 squared. Next, simplify the complex fractions. So the first thing I'm going to do is rewrite this. So this would be 3x over x minus y times the reciprocal. And I'm going to write the reciprocal in factored form. So my denominator here goes now on top. So I can factor out a 4. That's actually a difference of 2 squares there. So this would be 2x squared minus 2y squared times, I'm going to make that 2x squared plus 2y squared. And then I'll have a difference of 2 squares left over. So that would be, actually, no, that would be 2x squared minus 2y squared. And then that's all going to be divided by 6xy. So now I can multiply them. I can look at, see what's in common with the numerator and denominator. I can take out a 3y here, or 3x here, divide a 3x here, and I get a 2. Now I'm left with an answer of, in the numerator, in all 4 of these, I can take a 2 out. And if I take a 2 out, I now have x. Actually, this one I actually did incorrectly. So for here, going back to the beginning on this one, I can factor out a 4. That leaves me with x squared minus y squared, which is a difference of 2 squares, which will now give me 4 times x minus y times x plus y all over, now I have x minus y times 2. If I simplify that, actually this would be 2y. I simplify it, x minus y is divide out. Divide a 2 out here, divide a 2 out here. I get a final answer of 2x plus y all over y. Next one, I'll rewrite this one so I can factor a 3 up on top. So this is x minus 3 divided by, this would be x plus 2 times x plus 2. And multiply by the reciprocal, which this will make this 3 minus x down here. And on top I have x plus 2 and x plus 12. Now to simplify this, the x plus 2 is divide out. I could also factor out a negative 1 here. If I factor out a negative 1 here, this is going to equal negative 3 times negative x plus 3, which that will cancel off here. And now I'm left on top as a negative 3 times x plus 12 all over x plus 2. And this would be my solution. And our last question here, simplify this one. So I have difference of two squares on top, so this would be x minus 3y times x plus 3y all over xy, multiplied by the reciprocal. I have x times x, and then I can factor out 2 in the denominator. That leaves me with x plus 3y. Now if I look, I have x plus 3y here and x plus 3y there. I have an x here and x here. Nothing else in common, so my answer would be x times x minus 3y all over 2y. So that's our lesson on multiplying and dividing rational expressions.